I want to go to the other end, literally and figuratively, and talk about gut health. Because up until now, and
I
certainly,
see what you did with that pun.
and certainly in the last few minutes, we've been talking a lot about sort of top-down processes, the brain, the psychology, placebo effects, but the very real aspects of those. Not that I can imagine 2,000 calories is 1,000 calories and somehow change the law of thermodynamics. Can't do that. But we've been sort of top-down in integrating a lot of different ideas into weight loss, maintenance, and weight gain. But gut health, at least the more popular studies on gut health, have kind of blown a lot of things out of the water. For instance, this idea that you could take obese mice and literally give them fecal transplants from lean mice. And yes, that sounds like what it sounds like. Fecal transplants definitely inserted through the same end in which it comes out. And I point that out because a lot of people have asked me that they, it was kind of scary to me. I thought, yes, this is not about ingesting feces. This is they literally do a transplant of feces from lean mice into obese mice, and the obese mice get lean. And yes, this has been done in humans, limited number of studies, and observed some pretty impressive effects on weight loss that I have to assume could be related to placebo effect. They might have told these obese people, hey, look, you're going to get lean through this fecal transplant from lean people. But more likely, it had some effect on their core physiology. I don't know which aspects, although I can speculate which ones. And they became leaner. They lost weight. And that is, in some sense, miraculous, especially given the important role of psychology and exercise and satiety signals, because I'm going to assume that they controlled for a number of those other variables, although no study is perfect. Right. What are your thoughts about gut health as it relates to metabolism, energy utilization, and balance?
Yeah, so the first thing I'll say is I'm not a gut health expert, but I feel relatively comfortable talking about it based on conversations I've had with people who are experts. One being Suzanne Devkota, who's, are you familiar with her?
Well, she's sort of a phenom in this area from what I understand.
So she was actually doing her master's when I was doing my PhD in Lehman's lab. So she was one of my lab mates.
Terrific.
And, the other thing to say is even gut health experts, and Suzanne will tell you this, they're like, talk to me in 20 years. We just know so little. And I think that's an overall thing that people don't understand is the scientific consensus moves very, very slow. And probably for good reason, because if we just flipped our scientific consensus based on one study, it would be a mess, right? So it's going to take time before we really understand the implications of the gut and what it means. So when it comes to weight loss, there probably is a role in there. We've seen that there's something going on. Now, whether is it something where a gut microbiome makeup that's more obese resistant, perhaps it extracts less calories out of the food you eat, right? Or perhaps it's elevating BMR, although I think that's probably somewhat unlikely.
Do you think it could impact the way satiety signals are?
So
back to the brain again is the question.
We know that there's a link in the gut-brain axis. And so my suspicion is that it probably is working via appetite regulation. So that, if we look at the most effective obesity treatments out there, which is like semaglutide, you consistently see a 15% on average loss of body weight, which is massive, and people keep it off. That is a GLP-1 mimetic, which is a gut hormone, and it basically just is a very, very powerful appetite suppressant.
I guess I'm interrupting, but hopefully with a purpose.
Go ahead.
There's this really interesting study, and it's in mice, admittedly, but published in a neuroscience journal recently. And basically the takeaway is that, like so many things in neuroscience, the GLP-1 works in two parallel pathways. In the brain, it seems to impact neurons in the hypothalamus that control satiety, so exactly what you're saying. And in the gut, it seems to create an activation of the mechanosensors in the gut. Mm-hmm. So the perception is that the gut is full, mm-hmm. or fuller, I should say, not full, because I think people who take semaglutide don't feel bloated. I don't know, they might, but that one feels as if their gut is actually fuller because these mechanosensors that send stretch are sending signals to the brain. Oh, like I actually have some food. I'm not empty down there.
Right.
Anyway, I'm tickled by this result mostly because every time I hear about a drug or a molecule having effect, we think it has an effect at one location. But it's kind of interesting that, especially for something like appetite regulation, that it would be impacting body and brain in parallel. Anyway, forgive me.
That's okay.
You can tell I'm really excited about this. And here you are telling a neuroscientist, me, that a lot perhaps circles back to these brain mechanisms of satiety.
Yeah. I mean, I think that, and especially looking at the research on leptin, like we used to think, okay, metabolism is mostly like liver based, and then there's metabolism in the adipocyte and skeletal muscle, but none of this stuff exists in isolation. There's so much crosstalk between these pathways, and that's when we get into mechanisms. One of the things I love mechanisms. But one of the things I tell people is keep in mind that when you're dealing with an outcome, right? So like when I say outcome based, we're talking about physical outcomes like weight loss, fat loss, changes in blood markers, whatever. Though that is the summation of thousands of different mechanisms. So sure, sometimes you can affect a mechanistic pathway and you get kind of straight down the line outcome, but not always. Whenever you make a treatment or kind of anything into the system, it's like throwing a pebble in a lake, right? It creates ripples. And we don't always know what those are going to be, right? And that's why, we've seen, certain drugs, well, it works on this pathway. And then they list off all the side effects. And you go, well, how would it create that many side effects? It's because nothing, for the most part, they don't just work in one place. There's a multitude of places it works. And to your point about semaglutide and the effects on mechanosensors, it's probably why a lot of people report actually kind of like low-grade nausea when they're using semaglutide because of that. Because if you're, that feeling is usually not like a real comfortable feeling, but it will get you to not eat. So I think there's absolutely likely a connection. But we haven't fully elucidated how that works. And when you think about how complicated the gut is, I think I heard something like there's more cells in our microbiome by far than there are in our body. So we're actually more, in terms of a cell per cell level, we're actually more bacteria than we are eukaryote, right?
There's Justin Sonnenberg, who's one of the world experts on microbiome. He's in the lab upstairs from mine at Stanford. And he has this idea, it's just an idea, that because we are indeed more bacteria than we are cells, the question is who's the host and who's the passenger? Like maybe we are just, maybe they're exploiting us to take them around and interact because they interact and grow on one another. And so this idea, this freaks people out. Lex Friedman will love this, that maybe human beings are just actually the vehicles for the microbiome and not the other way around. Anyway, kind of a scary thought. Do you do anything specifically to support your gut microbiome? Are you a probiotic guy or a fermented foods guy or a fiber guy?
So again, I'm going to kind of go straight down the line from what I've heard from Suzanne and other experts. So if you want to improve gut health, one of the biggest levers, the three biggest levers you can pull is not eating too many calories, exercising. There is a connection between exercise and the gut, and fiber. So it is, of the things we know, dietary fiber seems to positively impact the gut because it is what's called a prebiotic. So your gut microbiota can take, especially soluble fiber, although there's actually some evidence, at least in mice, that it might be able to use some insoluble fiber as well. I think Suzanne was doing a study looking at hemicellulose and actually seeing that some specific forms of microbiota flourish with hemicellulose, suggesting that they may actually be getting some kind of fuel out of it, which is really interesting. But again, in mice, so just huge caveat. So your gut microbiome can produce these short chain fatty acids from by fermenting this soluble fiber, and there's quite a bit of evidence that these volatile fatty acids, which can be then actually reabsorbed in through the liver, that they have some positive effects. Like for example, butyrate, when they've done butyrate supplementation, they've actually seen positive effects on insulin sensitivity. So what we seem to understand is that more diversity seems to be better. Fiber seems to be positive. Prebiotics seem to work much better than probiotics.
Supplemented prebiotics.
Yes.
Yeah.